Thank you for joining this lesson. We're going to look at exterior common tangents to two circles. So we are told that A, B, C, D, E, F, G, A is a belt tied around two wheels whose centers are O and Q, forming a pulley system. Given that Q equals to 36, then OA equals to 5 centimeters, and BQ equals to 7 centimeters. Calculate to one decimal place, taking pi as 22 out of 7, the angle AOQ. AOQ. So this is the angle we intend to calculate. There are a few things we should understand about the common exterior angles for two circles. And one is that when we have such tangents, in the construction of the tangent, we should know that there is a circle which is constructed inside the bigger circle such that the radius of this circle is R1 minus R2, the bigger circle minus the smaller circle. So it means there is a small circle here in the construction of the common tangents exterior, such that now its radius is the difference between 7 and 5, because I can see the radii here are 7 and 5. Then we have a radius of 2 here, such that now in case we draw a line from center O to this other small circle, now we will be having a line which is parallel to this one, and now that this is 5, we will also have another 5 here. Therefore now we're going to use these 2 and this 36, because this one is right angled, to know several angles in this in this pulley system. So with 2 and 36, and this one is an angle, this one is an angle, then we need to use some trigonometry, and I would prefer, because we have a length, the hypotenuse, and the angle which is just adjacent to this length, then we use cosine. So we will talk of the cosine of theta to be given by 2 out of 36. That means cos theta equals to the adjacent length over the hypotenuse. So to get theta, we need the cos inverse of 2 out of 36. So 2 out of 36, shift cosine or cos inverse of 2 out of 36, and this gives us 86.82. 86.82, but to one decimal place should be 0.8. Therefore 86.8 is the angle here. That means if this is the angle here, and AO is usually parallel to BQ, then it means the angle on this side is also 86.8. So we have 86.8 and 86.8, which means along the straight line now, for us to get the angle AOQ, this one now, we need 180. We need 180 minus 86.8. Remember, it should be to one decimal place. So we're getting 93.2. So the angle here is 93.2, which means we can obtain now, or instead of calculating what have not been asked, let me be guided by the question. The length of the belt in contact with the wheel whose center is O. So the length of the belt in contact with the wheel O center is O. The length of the belt here, which is in contact. Therefore, the length of this belt, we'll need the whole of this ankle. The radius is already given. So we'll need 86.8 times 2, the whole of this ankle. Therefore, I'm going to say arc length, or length of an arc, is usually given by theta out of 360 2 pi r. So this means I'll use 173.6 out of 360 times 2 times pi times a radius of 5. So this one divided by 360 times 2 times 22 out of 7 times 5. This is going to give me 15.15, but remember we are calculating everything to 1 decimal place. So this will be 2 centimeters. So the length of this belt, which is in contact with the wheel O center, is O. We need to get the 86.8 we were having times 2 to get 173. The now arc length is given by theta over 360 2 pi r. So this length is already obtained. Now we also need to get the length of the belt in contact with the wheel whose center is Q. So the wheel whose center is Q now. Now that we calculated 86.8, we need to understand that this other side is having 93.2 also. So 93.2, and we multiply by 2 to get the whole angle now. So 93.2 times 2. This gives us 186.4. So we'll use 186.4, the theta here. 186.4 as the theta to get the arc length, or the length of that belt on the other side. So we'll need 186.4 out of 360 2 pi and a radius of 7. Therefore, I'll multiply, or I divide this one by 360. Then I multiply by 2. I multiply by 22 out of 7 times 7. This is going to give me 22.8 to 1 decimal place centimeters. So this is the length of the belt, which is in contact with the pulley, O center is Q. This length. Then now, finally, we are told to calculate the length of AB, hence the total length of the belt. Length of AB should be calculated by, remember we just need, if we call this one X, we need OX. And we can use Pythagoras theorem, because this is 36, this is 2, and this one is hypotenuse because the right angle is at this point. Therefore, we can use Pythagoras theorem, whereby OX will be equal to AB, and this will be given by the square root of 36 squared minus 2 squared, because this side is 2, this is 36. So 36 squared minus 2 squared, and this is giving us the square root of 1292. So the square root is going to give us 35.9 centimeters. That 5.9, sorry, centimeters. So with the length AB, that 5.9, we are also supposed to get the total length of the belt. So we had this length, this length, this length, and this length. So we're going to use 35.9 times 2 because of this other length, ED. So 35.9, that is, times 2 plus the first arc length, which is 15.2 centimeters, plus 22.8 also centimeters. So I'm going to start with 2 times 35.9 plus 15.2 plus 22.8. So this is going to give me 109.8 centimeters. So that is how we handle a question on exterior common tangents to circles. Thank you for following. Subscribe and share.